Hi everyone, I'm Aaron and my groupmates are Choo Kean Yee and Chiam Zheng, and today I'll be sharing my group's data science project of the famous March Madness basketball tournament in the United States. March Madness is a pure knockout tournament for the best college basketball teams in the country, as can be seen in this bracket on screen showing the many teams and games to be played. This video will consist of the following topics. Firstly, I will bring you through the problem statement, datasets and motivations for choosing this problem. Next, I will share our data analysis and exploration techniques used. After which, we will dive into our chosen machine learning models to explore how we can attempt to build a model to solve our problem. Lastly, will be the findings of our data science project. We aim to explore the various factors that contribute to a team's success and to use that to see how well we can predict future performance. As such, this led to our problem statement: what are the key performance metrics that determines a team's success in this tournament? In turn, can we use these metrics to build a model to make better predictions? We adopted two datasets for our project. The first will be the past NCAA tournament data from 2008 to 2022. The dataset contained information such as individual team performance metrics like percentage free throws or 3-pointers made, and also the end result of each team in each year respectively. This dataset will be what we use to determine which factors are the best for predicting success. The other dataset will be the 2023 pre-March Madness tournament statistics, and of course, without the end results. Being sports enthusiasts, the March Madness tournament is a hot topic every single year, with exciting matchups and big upsets every year. This year, it is expected that 68 million Americans will place $15.5 billion in bets on March Madness, according to the American Gaming Association. Thus, making good predictions is vital and could be the difference between winning and losing money. Just for context, the chance of predicting the Elite 8, which is the top 8 teams of this tournament, purely by chance is only 12% and is obtained by taking 8 teams out of 68 total teams for the tournament, making this a very challenging proposition in the first place. Therefore, we were interested to see how far we can go and build a model to improve our odds. We began our data exploration with a variable we were attempting to predict, round. From the data shown here, the round variable is a numeric value that indicated how far the team went in the tournament. The rounds available include 68, 64, 32, 16, 8, 4, 2, and 1. For example, 68 will be assigned to the team who were knocked out in their very first game. Contrastingly, 1 will be assigned to the champion team that won all their games and the tournament. We noticed that the data type for round was integer. As such, we decided to change the data type to categorical, as we were only concerned with the teams that made it to the top 8. We also reclassified the different round categories as either Elite 8 or not Elite 8. Now that we have found and cleaned our response variable, we have to now look for suitable predictor variables from the dataset. The machine learning portion. First, we explored the Poisson model, which was something we learned outside class. The Poisson model is commonly used to model count data and predict events in a given time frame or space. Although it may not be the most obvious choice for predicting the successes of basketball teams in the March Madness tournament, there are a few reasons why we still considered it for our project. The Poisson model can be used to predict the number of times a team reaches a certain stage in the tournament, which can be treated as discrete count data. Since our problem statement revolves around identifying key performance metrics that determines a team's success in the tournament, the Poisson model can help us understand how these metrics contribute to a team's frequency of reaching the top 8, for example. By fitting a Poisson model to our data, we can compare the coefficients of different performance metrics to determine which factors have a more significant impact on the team's success. This information can then be used to inform our model selection process and refine our predictions. Lastly, it is always essential to explore different modeling techniques in any data science project to find the best possible model for the task at hand. Considering the Poisson model allows us to assess its performance relative to the other models that we tried. From the Poisson model, we can see that the following variables are the most important factors in determining a team's success. We then realized that some of the limitations of the Poisson model were over-dispersion and non-linear relationships. So due to these limitations, we deemed that the model was not very suitable and we decided to go with another model instead. However, the Poisson model was still useful in telling us which variables will be the more important factors in determining a team's success. With this info, we could use the variables identified here in other models. Next, we chose to revert to a model we learned in this course, which was the multivariate classification tree. Here are some reasons why we chose to use a classification tree for our March Madness prediction problem. Interpretability. Classification trees are easy to understand and visualize, making them highly interpretable. This is important in a sports context like March Madness, where explaining the model's prediction to non-technical stakeholders such as coaches, team managers, or fans is valuable. Handling non-linear relationships. Classification trees can capture the non-linear relationships between predictor variables and the response variable, which can be beneficial in a complex scenario like predicting the success of basketball teams in a tournament. Feature importance. Classification trees can provide insights into the importance of different predictor variables. The higher the variable appears in a tree structure, the more important it is for making predictions. This can help us identify key performance metrics that determine a team's success in the tournament. Minimal data pre-processing. Classification trees do not require extensive data pre-processing, such as normalization or scaling of predictor variables. This can simplify the modeling process and save time during the analysis. Robustness to outliers. Classification trees are relatively robust to the presence of outliers in the data, as they use binary splits to separate the data, which can be less sensitive to extreme values, thus like linear regression. Using the identified variables from the Poisson model, after building the model from the confusion matrix, the top row is what we're concerned with. We can see that for the training set, 54 out of 90 were true in predicting the Elite 8, and in the test set, 10 out of 22 were true. From the random odds at the start, which were 12%, to 60% accuracy in the train set and 45% accuracy in the test set, this is an improvement using the model. However, classification trees do have some drawbacks, such as the tendency to overfit the data, which can be mitigated by using techniques such as pruning or employing ensemble methods like random forest. Despite these drawbacks, the classification tree offers a suitable modeling approach for our problem due to its interpretability, ability to handle non-linear relationships, and simplicity, making it a justifiable choice for predicting team success in a March Madness tournament. Trying to improve on the limitations of the classification tree, we decided to use a random forest. The random forest is a supervised learning algorithm that uses the ensemble learning method. The ensemble learning method is a technique that combines the prediction from multiple machine learning algorithms to make a more accurate prediction than one single model. Similarly, using the same predictor variables as before, plotting the confusion matrix, it gave us a 9 out of 22 accuracy rate for predicting the top 8, which is comparable to the one we got from the confusion matrix in our classification tree model. Now, on to our conclusion. Overall, with the improved classification tree, we managed to obtain a 45% accuracy in predicting whether the team will make the Elite 8. While in the data science realm, this may seem like a mediocre result, but it is actually a very good improvement from the 12% initially, considering the difficulty and complexity of our predictions. The factors that affect our predictions include changes in patterns. The factors that determine success of teams in previous years may have changed in 2023. For example, there could be new strategies, coaching staff, or rules that impact the performance of teams. In such cases, the model trained on historical data might not have been able to capture these changes effectively. Variability in sports. Sports outcomes can be inherently unpredictable due to various factors like injuries, form, and even team dynamics. The variability of sports outcomes can make it challenging to develop a highly accurate model. Small sample size. The Elite 8 is a small subset of the total teams in the tournament, which means that even a few incorrect predictions can significantly impact the accuracy score. As such, the ability to predict the outcomes of the March Madness basketball tournament may still be very difficult, but our model has shown an improvement, and as we continue to learn and grow in the area of data science, we may one day find a better way to do it. Thank you.